Well, hello and welcome to our realm of mathematical adventures. I'm your host, Mr. Lupke, and it's an awesome privilege to welcome you, our mathematical legionnaires, as we discover the beauty that is mathematics. Today we're going to be talking about segment addition postulate. Postulate is just a really fancy word for a rule that we all accept to be true. Okay? But we're going to talk about segment addition. Now, these two words here, we already probably know. We know what a segment is, a part of a line. Addition, we know that means we're going to be adding some things. And so we're going to be looking at a rule we accept to be true that we're going to add segments together. Let's see how this rule works, shall we? Okay, so here's the rule for segment addition postulate. Let's say we have a segment like this. Here we have a segment, and on this segment we have points A, B, and C. Now, this long, big segment here, segment AC, can be broken into two smaller segments, segment AB and segment BC. So 3 points on a segment, okay, A, B, and C. Looks like I have, the big one looks to be a composition of two smaller segments. And then we have this description that says if points A, B, and C are collinear points, that means they're on the same line, which they are, and B is between A and C, well, B is definitely in between A and C, well then we have this rule that we can use. We can use the segment addition postulate, which pretty much just says this. Segment, the measure of segment AB, notice I didn't put the line on it, plus the measure of segment BC, right? The two smaller ones is going to equal the measure of segment AC. Long story short, tiny segment 1 plus tiny segment 2 equals the whole segment. That just seems so logical, doesn't it? This piece plus this piece makes the whole thing. That's the segment addition postulate. Now let's take a look at how we actually do those rules, how we actually use those rules in solving some problems. All right, here we go. Okay, here's our first problem. And here I have a segment EF. And the question is asking me to find the length of EF. So I know that from E to G is 2.5 inches. And from G to F is 2.8 inches. So how can I use the segment addition postulate to be able to find the length of EF? Well, let me give you a little strategy here. Here's what I'm going to do. I'm first going to write the segment addition postulate using the names of the segments. And I'm going to do it the same way every single time so I don't confuse myself when the problems get tougher. So I'm going to write here first, segment EF. Oh, mistake. Let's erase. Whew. See, even I make mistakes here too. So we've got segment EG, which is from here to there, plus segment GF, which is from the middle to here, equals segment EF. That's the whole segment. Now that I've written this out. We know this is true. That's the segment addition postulate. Now that I know that, we're just going to substitute some values in and be able to solve for EF. Well, we know what the length of EG is. It's 2.5. So let's put 2.5 in. Plus, well, what's the length of from G to F? Well, that's 2.8 right here. We see that. So I put 2.8 equals EF. And now this equation here tells me I need to add those two together. So I'm going to add those two together. So 2.5 plus 2.8, that equals 5.3 equals EF. Now our answer is almost done because in the problem we have labels. So let's put our label in here. 5.3 what? EF. So I'm just going to rewrite it here. EF equals 5.3 inches. And that's all there's to the problem. Really simple. Now let's go take a look at what happens when we're not solving for the length of the large segment. Okay, here we go. Okay, now in this example, we're not solving for PS, the large segment. We're solving for the length of PR, one of the small segments. But we're going to do the exact same thing we just did. Okay, first we write the segment addition postulate using the segment names. So small length here, which is PR, plus R to S, and that's going to equal the length of PS. So I do that. Perfect. I've got the basic idea down. Now just plug in values where you know. From P to R. I don't know what that is, so you could choose to leave it as PR, or remember algebra, when you don't know something, you can make an X, make that an X. So I'll plug that in as an X. All right, cool. Plus RS. RS is 3.7 equals PS, which is 5.8. Now we have an equation, and we know how to solve this one-step equation. Just subtract 3.7 from each piece. So I subtract 3.7 from both sides, because remember, we got to keep it in balance. And I get X equals 5.8 minus 3.7. Well, that's 2.1. So 2.1. Now, we got to answer the question. What's the length of PR? PR equals, let's put it up here. PR equals, well, that's 2.1 what? Millimeters. And we've answered our second question. All right, let's take a look at a special case of segment addition postulate with these numbers. All right, here we go. All right, take a look at this example right here. We've got some interesting marks here, but we know what those marks are. Those marks are congruent marks. That means that the segment from W to X is equal or is the same length to X from X to Y. And we're going to use that to solve this problem. Find the length of WX from here to there. Well, here's what we know. We know that this length is equal to this length. Well, guess what? Since that's 6, we just divide that by 2. We know it's going to be 3, but let's show you how to do it mathematically. Here we go. WX plus XY equals WY. We know that from our segment addition postulate, but we also know that WX and XY are equal to each other. So let's make them both X, since that's what we're solving for. And then WY is 6. Combine our like terms, this becomes 2X equals 6, divide by 2, and we know that X is going to equal 3. So now we can answer the question, because we said that X represents WX. So I'm just going to write here that WX equals 3 centimeters. Absolutely. And now we've just solved our next problem. And now we're ready to step this up to the next level and incorporate some harder algebra. Let's do that. Okay, my mathematical legionnaires, guess what? We're incorporating some algebra into our segment addition postulate now. And you know what? It's really just as easy as it was with the numbers. We're just going to have to solve a little harder algebra equation. Here we go. Let's get started. We are asked to find the value of X. Now we see that B is still B between A and C, that these segments, small segment plus small segment equals a large segment. So let's use segment addition postulate just like we have been. So we go and let's write it out. AB plus BC equals AC. There's that equation. I recommend writing that out, because now it makes the substitution a whole lot easier, especially when things are going everywhere with our expressions and we're trying to write the equation. Well, if we start with this, it's easy to write the equation because we just have to plug our values in now, because we already know how the equation is supposed to be set up with the segment addition postulate. So now let's substitute things in. AB it's X. Absolutely, it's X. Plus, what's the length of BC? Well, we go over here and we see it's 2X. So we'll put 2X right in for BC. And now we look, okay, what's the length of AC? AC is, well, look, it's 2X plus 5. So I'm going to write 2X plus 5. And now I just need to solve this equation. On the left side, I need to combine like terms. X plus 2X. We know that is 3X. And then over here, I can't combine, so I'll just write it down. So here's my new equation. 3X equals 2X plus 5. Now, I need to move this 2x over to there so we get all our x's on the same side. This is solving an equation with variables on both sides. So to do that, I subtract the entire term, minus 2x on that side, minus 2x over here. Okay? Those cancel out. See you later. They're gone. And then what am I left with on the left side? 1x equals. And I bring down the 5. And lo and behold, I now solve for x. And that was my goal. Find the value of x. And we did. It's 5. So now, let's take a look at how we can solve other types of problems with segment addition postulate. Okay, Math Legionnaires, this problem comes up all the time. And you know what makes this problem really hard? There's no picture. But you know what? We can draw a picture because we know what that looks like. It says find the value of x and yz if y is between x and z. Y is in between x and z is code word for segment addition postulate. So let's draw the picture first. Here we go. So I'm going to draw a picture here of segment, put a dot, put another dot. It says y is between x and z. So that means y has to be in the middle. Then we'll go between x and z. It doesn't matter which side you put the x and z as long as y is in between them. Now, we're asked to solve for the value of x, and we got to solve for yz. So we got to find two things to answer this question. And then we get to our descriptors. Now, it's important to make sure we plug those descriptors into the picture. xy equals 2x plus 1. So I want to place 2x plus 1 up there for xy. This is going to help us out. Then I go yz equals 6x. So let's put 6x up here. Again, this is to help us see the problem so we could solve it correctly. And then finally we have xz is 81. That's this length right here, 81. Now we're ready to solve our problem. Start by writing the equation using the letters, and that is xy plus yz equals xz. Now that I have that equation written, all I have to do is plug my values in and solve. xy is 2x plus 1. Okay, that's all the xy. Bring down the plus sign, bring down the addition sign, and plug in the next term, which is 6x for yz. Bring down the equal sign, and now what does it equal? Equals 81. So let's plug 81 in right there. Now it's time to solve. All my x's are on the same side, but there's multiple terms. So let's combine like terms to solve this. 2x plus 6x is 8x plus 1 equals 81. Subtract 1 from both sides now so I could solve this. I get 8x, cancels out, equals 80. Divide both sides by 8, and x is going to equal 10. Whew, there we go. We solved the problem. No, we didn't, because it asked us not only to solve for x, but what is yz as well? Where's yz? Yz is this right here, 6x. So you know what we have to do? We've got to take this and plug it in. So let's do that. We've got yz equals 6 times x. X is 10, so let's plug 10 in. And then I got yz equals 60. And now I've answered both questions, and you'll get full credit on that test when you do both, solving for x and solving for yz. Okay, we've got one more example here, and this is a really tough one because it deals with midpoints. Let's take a look at it. All right, here's our last type of problem with our segment addition postulate. But this one's kind of like a special case because in our directions it tells us if h is the midpoint of gi, that means this point right here is equidistant to both g and I. It means that gh is congruent to hi, and that changes everything about this problem because we don't know the length of gi, but we know that gh and hi are equal to each other. So we write that as our equation here. gh equals hi. And now just plug in our values. Here we go. I know this is 5x plus 2 equals 9x minus 10. It's time to solve. I'm going to subtract 5x from both sides. I get canceled out. That gets 2. This becomes 4x minus 10. Add 10 to both sides. You know how to solve these equations. I don't need to keep reminding you. So that's 12 equals. Those cancel out. So I get 4x divided by 4. And that means x is going to equal 3. I know what x is. But that's not what the question asks us. The question asks us, what's GH? GH is over here. Plug it in, and we're ready to go. GH equals 5 times what? 5 times 3, you got it, plus 2. So I know what 5 times 3 is. That's 15. Plus another 2, that's 17. And now I've answered the question. GH equals 17. I hope all these examples have helped you out, and I'm looking forward to seeing you in class ready to go solving these with expert precision. All right? Keep practicing those problems, and I'll see you next time.